So this is going to be broken up into two parts. First, I'm going to do a quick introduction, or maybe not that quick of an introduction, to EigenLayer specifically for developers. And then I'm going to walk through building a very basic AVS. And this doesn't talk much about the restaking part because that doesn't really have to do, I think, with this audience. Instead, we're going to just talk about why EigenLayer exists. So if you want to check out any of the resources that I'm about to share, you can check this out. I think that for the purposes of people here that are interested in building, there is a repo called Awesome AVS that is essentially an aggregation of all of the best learning material. So if you want to build anything, that's what I would recommend checking out, but there's also some resources here. So when I first heard about EigenLayer, it wasn't that interesting to me because everything was talking about restaking, and I'm typically just not too interested in what I at that point thought was like the financial part of the whole system. It was only once I understood kind of like why the staking existed that it became interesting to me. And the basic value proposition is this: it's that if a developer wants to build out a new network, a new protocol, or any type of system that requires some type of verifiability, they have to bootstrap their own economic security, which is not a trivial thing to do. If you want to write a smart contract, that's a pretty trivial thing to do, and you can inherit $500 million or $500 billion like, of economic security from Ethereum by just writing a smart contract. But what if you want to build other proof-of-stake networks? What if you want to build another chain? All of those sorts of things, you have to basically kind of start from scratch. So the core challenge is this: it's that bootstrapping decentralized infrastructure is difficult. And EigenLayer, the whole, I guess you could say, the purpose that it serves, or the means to the end of the whole restaking, is that it provides a platform for developers to build arbitrary proof-of-stake networks by inheriting the economic security of Ethereum. So with EigenLayer, users that restake their stake that they're already using to secure Ethereum, you can kind of bring that power of Ethereum outside of the EVM. So we're used to having that economic security within our smart contracts, but you can kind of extend this beyond to build out arbitrary networks. So I like TLDRs because they kind of like take a bunch of mumbo jumbo and kind of make it really succinct. So a couple of TLDRs here. You could think of EigenLayer as shared security for Ethereum, or increasing the programmability of Ethereum. So what does that even mean? It just means that right now you can program smart contracts, but with EigenLayer and similar products, you can program anything. So what does shared security look like in practice? I'm probably preaching to the choir here because I know that it's a very highly technical group of folks that come here and also to ETH Berlin where I just left. But let's talk about the evolution of blockchains for just a moment. The original networks were application specific, meaning that if I was a developer and I wanted to build out a new idea, I had to literally build the whole blockchain from scratch. So therefore we had application-specific chains like Bitcoin and Litecoin and all of these other specific things that were essentially slightly different from the other. But no one could kind of pick up a single line of code and deploy it and then have a new blockchain or new decentralized app that inherited any of that security. It just didn't exist. So the big, I guess, evolution in this entire industry was blockchains that were programmable. So programmable blockchains, smart contract blockchains. And the first one was obviously Ethereum. So it was a big deal because you could take a single file and now have a specific set of functionality that you described in that file. And you did not have to build all of that infrastructure. You could kind of describe what you wanted. So examples are any smart contract that became successful that is now a product. Uniswap, all the DeFi protocols. You have now all the L2s with social networks and all of these things. But the underlying network that kind of enabled all of that was a smart contract platform like the EVM running on something like Ethereum. But what we've gotten to realize, what we've become to realize is that scalability does not provide, the current networks do not provide the scalability of what we want to have if we start comparing the usage to what we might see in the traditional Web 2 world. So in the Web 2 world at AWS, where I worked for a while, we had a database called DynamoDB, and DynamoDB would manage literally 100 million or so operations per second for a single application. So a single application using their own database was hitting millions or tens of millions or even up to 100 million operations per second. This was not a shared blockchain or a shared infrastructure. This was just for them. And if you kind of compare that to where we are in the blockchain world, where we have what we consider fast network or performant network, like Solana, for example, maybe you might disagree with that, whatever. But let's just say that Solana can do 10,000 TPS, real TPS, which that is obviously something that can be argued. But let's just say that it did do that. Solana is also a shared network, so it's shared by every smart contract or program that's been deployed, and it's also shared between all of the users of all of those programs. So what has happened is that we've realized that there needs to be more scalability, and there are two approaches to scalability in software. You have vertical and horizontal. Vertical is making the execution faster. Horizontal is splitting up the work across multiple nodes. So what has been realized in our space also is that we need to scale both. So we're seeing new execution environments, better execution environments, but we're also seeing this roll-up centric roadmap where people are trying to build out application-specific networks, application-specific roll-ups, and have interoperability between them. So we want to make the execution extremely fast. We want to have anyone that needs their own application in the future potentially have the ability to deploy their own network and have everything interop in between. And that is kind of the end goal. We're not anywhere close to that yet, but that's kind of what's being worked on, right? So with this, we have this modular paradigm that came into play that was introduced, I think, this name originally by Celestia. So with the evolution of blockchain networks, we now have roll-ups, which are decoupling the different pieces of the stack. And the very first one, again, was kind of like data availability. So we're decoupling this data availability layer, and now we're starting to see all these other pieces uncoupled as well. We're seeing coprocessors, we're seeing different types of execution decoupled. But with all of these new pieces that are being decoupled, a lot of these are essentially new networks that need to be built from the ground up. So with the modular paradigm, we're seeing new networks that need to exist, but there is only so much money in this space that can go to secure all of these networks. So every time a new network comes online, there has to be some money somewhere to be put to stake, to buy that token, to secure the network, blah, blah, blah. And if you think about this in terms of 5 years, 10 years down the road, imagine there being tens of thousands of networks. It just is hard to really imagine how that can be made possible if we go down the road that we're kind of going on with everyone building from scratch. So what is a solution to that? There are obviously multiple ways that you can approach this. I'm just going to talk about the approach that EigenLayer has brought to the table. So when you need a new service, the network needs its own distributed validation semantics to do verification. It typically needs its own token. And you need stakers and operators to opt into that network to participate in the network. So you need all these things, and you need to kind of bring them together. So the question is, what if developers could access Ethereum's validators? Or let's just say, what if developers could access billions of dollars of economic stake to secure their networks? And these are arbitrary networks. And the general idea here is that that's what EigenLayer enables. It's like these AVSs, which are actively validated services. You can basically deploy decentralized infrastructure without having to bootstrap your own trust network. I actually sent out a tweet on the way here it was kind of like something that I was thinking about. Because one of the things that I've actually heard, and this is kind of the point that I'm getting to here, essentially it makes it just a lot easier to build arbitrary networks. One of the things that someone said today, or this week, that kind of made me think, they said that, well, because it's going to be so much easier to build all these networks, we're going to see a bunch of like shit networks and shit coins and like just crap being built. And that's actually true, right? But when you think about it, that's kind of what happened with Ethereum, or that's what happened with the smart contract networks that are out there. You can fork, you can clone, you can deploy, anyone can do whatever they want. Is that a bad thing? I mean, some of it's bad for sure, but if you look at it as a whole, it's actually a good thing because you can learn from other people. There's new things that people are trying because they don't have to build all this stuff from scratch. So I think ultimately it's going to lead to a lot of innovation with a lot of crap along the way. So that's kind of like a side from my talk, but it's something that I was thinking about actually in the car ride on the way here that I just tweeted out. But if you want to kind of look at what this kind of looks like today, you have Ethereum or whatever network that you're building on. And then you have other services that you might be interacting with. And then you have your client that's interacting with one or the other or both. The general idea is you now have this stake here, let's say whatever, $500 billion. People are taking that stake. They're restaking it to these AVSs. The AVSs inherit this security. They are no longer having to issue all of these tokens to all these validators that are having an opportunity cost of leaving Ethereum to go to their new network, selling those tokens or whatever, and then kind of like buying into the new network. They're able to participate in that new network without, I'm not going to say without risk, but without, the best word might be them having to exit Ethereum, and I guess you could say it could typically would be more risky to join a new unknown network. So what are the network participants? It kind of looks like this. You have EigenLayer in the middle. You have application developers that are using different AVSs. And the AVS developers are interacting with the EigenLayer contracts. The operators are running the AVS services. And then you have stakers that are opting into different operators. And the stakers can choose which operators they want to opt into. There's also this idea of dual staking where you can use two different tokens to secure the same network. This gives a few different value propositions that a lot of AVS teams want, and it allows developers that are launching valuable networks to still have their own token and have a lot of utility for it. So yet another TLDR, AVSs are apps or systems or protocols or networks, whatever you want to call them, using Ethereum Trust outside of the EVM. So what are some categories? I'm going to look at some specific protocols that have been announced recently. We're tracking over 200 AVSs from teams that we think are good right now. There are probably about a couple of dozen that are publicly announced. These are different categories that we've put together. A lot of these categories kind of like cross over though, because some of these things will be used by roll-up services that are under other categories, and some of these will be interacting with each other, things like that. I think some of the more interesting ones, I think the most straightforward way to think about what could be an AVS, basically any existing successful protocol that already has been proven can be rebuilt as an AVS. Also, very specialized services that might not have made sense to build in the past. So imagine you have a service that is needed by your app and your app only, but maybe it doesn't make sense for everyone else's app. That might be a good I guess, choice for an AVS. If you also look at, I think, and I have a blog post, it's more of like a HackMD article I'm writing up right now, but if you look at what Farcaster did, I thought that was super interesting. They launched, a few years ago, And they just announced a big raise of like $150 million, which is really crazy at the app layer. What they built, though, to enable that app was like their own decentralized infrastructure that they had to kind of build themselves. So I wonder if we're going to start seeing more client-side applications become successful that are building their own proprietary or their own specialized networks to enable and facilitate their own specialized front ends. So if you are building in that manner, this also could make sense. So some specific examples. I think the most well-known example is data availability, because EigenDA was the first AVS to launch, or one of the first AVSs to launch. One of the reasons that EigenDA launched first was that it is very complementary to all of the AVSs that are being built now. So we have a lot of teams that are building using both EigenDA as well as creating their own AVS. A couple of the properties of EigenDA: very high throughput, low cost, reserved bandwidth. And I would say, like, if you look at data availability, there are a few different options now. I used to work with Celestia. Celestia's great. There's EigenDA, there's Avail. I don't think that one is necessarily better than the other. It's more about, okay, I have a product, I need this, that, or the other. I'm going to now look at all of the different options. I'm going to choose the best one. That's kind of the way I look at it. So some other examples of live or publicly announced AVSs. I just spoke yesterday on like this live podcast thing that I do with Versatis, who's building something called Allegro, which is really interesting. It's basically a verifiable DigitalOcean droplet. So you can spin up this DigitalOcean type droplet. You have your own server. You can do whatever you want. You can build services there. And they have different ways to implement verifiability of the things that are happening there. It's probably one of my favorite AVSs, because mainly it just has a lot of crossover with the full stack application development that I like to do, that I'm used to. It's more of a like real world use case that probably a lot of people are going to want to try, and I think they've already closed quite a few protocols that are well known to use that. Coprocessors are really interesting. So coprocessors are essentially a way to offload very computationally expensive things that you might have done in the past within your smart contract, outside of your smart contract. And they're asynchronous. So imagine you want to aggregate a bunch of information about a smart contract that's like an NFT contract or a token contract. You want to pull multiple queries, you want to do some stuff to that, and then you want to verify that on chain. Lagrange would allow you to do that. This is their API. It's actually a pretty nice API also. And the way that this works is that you basically have a way to initiate some type of process on chain. There is an off-chain computation, and then there's a callback into the smart contract. So you're verifying within the smart contract, and they have already gone live, and you can already start using their service. Another coprocessor is Brevis, very similar. It's a ZK coprocessor. They have a TypeScript SDK and a Go SDK that's pretty nice to use. I think Gajesh, who's on my team, is working on something there to open source it. Databases, data stores, and I think one other thing that they're working on is a vector database, or they're actually turning this also into a vector database as another option. So there's OpenDB. They basically provide a SQL API on top of any data that you want to have verifiable. This isn't an indexer, it's more like a true database. So you can store and read and query data, and all of the data is verifiable. And I believe they're also working on an archive node service for verifiable data there as well. Another one is witness chain, proof of location, proof of bandwidth. They also have proof of one other thing. I forgot what it is, but it's like a DPIN. We have AltLayer. AltLayer is building these things called restaked rollups, which allow teams to deploy a rollup along with their own AVSs for different pieces of the stack. So they have 3 separate AVSs that you can deploy along with your rollup. They have seen a lot of adoption so far. Yeah, Vital, Mock, and Squad, decentralized verification, fast finality, and decentralized sequencing. And then there's rollups as a service that are using EigenDA. I think Caldera, Conduit, Gelato, AltLayer are all 4 that you might have heard. And then the last one I'll mention, this isn't an actual AVS. It's using an AVS, which is EigenDA, called Mega ETH. You can think of them as similar to Monad in the fact that they are rebuilding a lot of the execution from scratch, and they're focusing on very high throughput, very low latency, and very low costs. Around 100K TPS is what they're saying, but I'm assuming that they'll probably launch with like closer to 10K TPS. If you want to learn and look at all the different ones that we have available, you can go to eigenlayer.xyz/ecosystem. I'm going to go quickly to my terminal and just run a Hello World AVS and then look at the code base real quick. So what we have is this very simple AVS that Gajesh built. And Gajesh is here with me again. He's on our team along with Wes. But basically, all this does, this is like the most simple AVS you could possibly think of. It verifies a string on chain. But all of the pieces are there to kind of build this out into something more sophisticated. But I think the whole idea is to get your mind wrapped around the different moving parts, build a mental model. So what we have are 3 files. These are like literally the only 3 files that you need to mess with to play around with this and kind of get everything to understand what's going on. There are a couple of different commands that are set, and you can read these and how they work in the README. But there is a command that starts the chain, deploys the contracts, and gets Anvil working. This uses Foundry. And then there's a command that starts the operator, which is essentially starting the service. So this starts a TypeScript service that we're going to go ahead and run. So let's take a look real quick at what's going on. So right now, we're monitoring for new tasks. Okay, so right now we're monitoring for new tasks, and we don't know what's going on because this makes no sense because we haven't looked at the code. So let's look at the code and come back. So the service that is running is here in index.ts. And we're going to go down here to the bottom where we have this main function. The main function is what happens when we start the service. We call a register operator, which registers the operator. And then we call monitor new tasks, which is a listener. And it's listening for an event to come from our smart contract. So monitor new tasks is here. The event that we're listening for is new task created. And when new task created gets invoked, we console.log the task, and then we call another method called sign and respond to task. And this sign and respond to task is the AVS specific verification that's happening. So let's go ahead and look at new task created. This is the smart contract. It's about 120 lines of code. Create new task is right here. We have a task that we create a name. We set a couple of other parameters like the block time or the block number, I guess. And then we store these in our local state. And then we emit this new task created. And then we call this sign and respond to task, which calls this right here called respond to task. And this is like the verification that gets done in order to essentially verify that this method has worked properly. There are a couple of checks. We have 3 checks. We check to make sure that we have the actual task ID is correct, that the operator hasn't responded yet. And then we go ahead and store that new task in our local state, and then we emit that the task has been responded. And that's really about it. The create new task function here is what we're going to be running next. And this basically is just going to actually go down here. It's going to be a set interval function that just creates a random task every 15 seconds. I might bump this down to 5 seconds. So if I go ahead and start that service, then this should create a new task every 5 seconds. So it should show up here. And there we go. We have a really basic AVS running. Now, this is obviously not too impressive in terms of like the functionality, but I think it's a really nice place to start to understand the different moving pieces within an AVS if you want to try to build something yourself. So we have a couple of hackathons that are happening right now that are, ours is mainly focused on developer tooling and education. So what we want to see built are example reference architectures like Hello Worlds and stuff like that. And you can be eligible to win up to 12,500 USDC and a trip to ETHCC. And if you go to the EigenLayer docs under resources, you can see everything about that. And then there's also an Encode Club virtual hackathon happening. And you can actually submit your projects to both. So if you hack on something in Prague, and then you can submit to both of these virtual hackathons also, I mean, at least to the best of my knowledge. I know you can submit to ours, but you can submit to both and be eligible for multiple prizes. But I would, if you want to get started building with EigenLayer, I would suggest to check out Awesome AVS, fork this Hello World, just run it, play around with the code, and then fork and possibly check out the more advanced Incredible Squaring, which is using our Go SDK. And that's about it. So thank you for checking out the talk. I encourage you to grab a programmable trust handbook if you want. There's only about 20 of them, like I said, but if you don't get one, come talk to me and I'll make sure I'll reserve one for you when I see you in ETH Prague. Thanks.